Hello everyone and welcome to the third session of Ahmed's Automation Lab. In the first session, we discussed programmability and APIs and we discussed automation in general. In the second session, we discussed CLI scripts and we created a simple script that can show the version of a switch and another script that can detect interfaces that are part of VLAN 3 and shut down these interfaces. In the second session, we calculated the time needed to run CLI scripts, and in this session, I will create similar scripts but using API instead of CLI. At the end of this session, we will compare the time needed to run API and CLI scripts to achieve the same results. So without any further ado, let's go to our session. Our session will be divided into different sections. First of all, we will talk about Swagger interface. If this is your first time writing APIs, Swagger interface provides you with a lot of tools that can help you in finding the correct syntax of your HTTPS requests. Then we'll talk a little bit about different requests like GET, POST, POT, and DELETE. And after that, we'll discuss login and logout. Same to CLI, you need to log in into API scripts and you need to log out after the end of your script. We will discuss these things in addition to response codes. What is the expected response code when you run any script? And after that, we'll discuss JSON format, mainly because JSON is the format that's used now by Aruba switches. It is very common format for API scripts, and that's why we will discuss JSON format in little details. And after that, I'll create two simple API scripts. The same way we created CLI scripts in session 2. In this session, I'll create two API scripts to do the same results or to achieve the same results as what we did in session 2. The idea of having these two API scripts is mainly to compare the time needed for CLI script against the time needed for API script to achieve the same results. So let's go to the details. This is our switch. It is 6300 switch, Aruba CX switch. So I'll start by logging to this switch with simple username password I have, which are admin and Aruba123. Once you log into the switch, you can see different widgets in the dashboard. We want to access the Swagger interface, you should go to API. This will open another window for Swagger interface. This Swagger interface is actually a documentation for API, and the good thing about this interface, it is live, which means whatever command you execute in this interface will run on the actual switch. So in my lab, this is my switch and this is the Swagger interface of my switch. As you can see here, I can get details about different APIs. For this lab, I'll focus mainly on port APIs. If you open the interface or if you open the port area, you will see different APIs related to ports. Some of these APIs are GET, which means these are read APIs that are used to retrieve data from that certain interface. The other request type is POST, which is used mainly to create. The first one is mainly to read. POST is mainly to create. Delete is for delete. And the last type is POT, which is used mainly to modify. If you want to modify certain value for certain port, you use POT. So let's go into action and try some of these. For example, let's say I want to view information about certain port, for example 111. I want to see certain information only. For example, I want to see the admin state, and I want to see the applied VLAN tag, mode, and trunks. So I want to retrieve this information about this interface. So let me test this API. Submit. This will show me the curl command, which is a tool that can be used to create APIs and create Python scripts. This is the URL itself if you want to use this API in different tools, for example. And this is the response. 200 means okay. You always want your response to be 200. Otherwise, the response code can be 304, 400, 401, which is common. If you are not authenticated or not authorized to run API, you receive 401. 200 is okay, which is the actual or good response code that you should expect. So by sending this URL, this request, you receive this information about the interface. The interface is up, it is access, it is in VLAN 2, and it is not a trunk. So this is a simple API that you can run in your switch without any scripting, and this can help you to know the URL request that you should send and the expected output results. So let's take this information and use it in our scripting. So let's take this information and use it in our scripting. I already have few scripts created in my Atom, which is the editing tool I use to run Python scripts. On the other hand, I have the CLI, I have the command prompt, I have the command prompt here to run this these Python scripts, and I have PuTTY here to verify from CLI different commands that we are running. So here I have the Python scripts, here I have my Windows command prompt, and here I have my PuTTY. So let's start by running the same script to get the version. In this script, I'm importing these libraries that I will use in my script. This line here is mainly to avoid or remove any warning related to certificate. As my API is running over HTTPS and I don't have the certificate of my switch in my PC, I want to avoid or disable the warning of HTTPS. This is the base URL for my APIs. Any API or all APIs are in this folder. Now in this script, I will use the session concept. This concept makes it easy to run multiple commands in the same session without worrying about cookies. The way it works is that once I log in to my switch, I'll receive a cookie. As part of this API request, I'll receive a cookie. This cookie, the same cookie, will be used in any subsequent request sent in the same session, which is this session. So any request coming using the same session will use the same cookie, so it doesn't need to authenticate again. Once I'm authenticated, I'll get the cookie. The cookie will be used in any subsequent request in the same session. And once I am done, I need to log out. As part of this logout, the cookie will be sent back to the switch, and the switch will delete this cookie from its database, and this will kill the session. So in all my scripts, I will use the concept of session to make it easy to deal with cookies. So as you can see in this script here, first of all, I log in using the username password. You don't need to type the username password here. Usually you use some other tools like, for example, getpass, which is a common tool used to retrieve or type passwords in a secure way. But in my script here, I'm not using the best practice. I'm trying to use the minimum number of lines to make my script easy and to make the idea, to focus on the idea instead of details of scripting. This line here is needed if you want to see the result of your request. For example, if you are not sure about the result code, or if you have any issue, this line can be used to show you the result code, which should be 200. Anything other than 200 is bad. So for example, one of the common response codes is 401, which means authentication or authorization issue. So 200 is the correct or the expected status code in normal scenarios. So let's try to run this script here now. Version underscore API dot py. So this API, it logged into the switch. It ran the API to get the software version, and then it typed the version using this line here. Once the version is typed, this API here is logging out to delete the cookie and delete the session. And at the end of my script, I added a few lines. These lines are needed actually only to show you how much time did it take to run this script. So this line here, these lines here, and this library here are mainly, or they are only to show the actual time needed to run this script. Why do I need this? I need this mainly to compare API against CLI to see how much time needed to achieve the same results using API versus CLI. So to run this script, it took less than 1 second, while if I run the same script using CLI, I have this Python script that I written before. It did the same thing. It reads CLI, it reads the version, but using CLI instead of API. So if I try to run the same function again, or the same script again but CLI instead of API, I was able to get the same data, but this time it took about 5 seconds using CLI to get the version, while in API it took less than 1 second to get the same data. So as you can see, API runs much faster and smoother than CLI. And also in CLI, I needed to read the lines one by one to go to line 4, second word, to be able to receive, to get the version. While in the API, this is API. In the API, I use JSON and dictionary. The way JSON works is using dictionary, which is somehow a collection of key value pairs. So this is called dictionary, which means the values in dictionary are arranged in a way to show the key and then the value of this key. So for example, in this case, if you want to see the actual JSON values received, I can, for example, I can print the version dictionary So if I print the results that were received using this API, instead of the format I created, so now I want to run the same script, but instead of printing which version is, then the version value, I want to print the results I got from this API as they are. I want to print the raw results I received from this version request. Let me save. So as you can see here, this is a dictionary. Now let's do more complex stuff. Let's assume I want to find all interfaces that are part of VLAN 3 and shut them down. Now there might be different reasons for this, but just for the sake of creating a script, I assume that we are looking for these interfaces to shut them down. So the same thing, I use the same library, I disabled the warning, I use the same base URL, and I started the session. I'm using the same session concept, so the same cookie received as part of the authentication session will be used in all subsequent requests until the logout. Once I log out, this cookie will be released and session will be killed. To be equivalent to my CLI session or to my CLI script, I created a loop to run over interface 1 to 29. For every interface, I will get the VLAN tag, and based on this VLAN tag, I'll compare the VLAN against number 3. If the VLAN is 3, if the VLAN for this interface is 3, I want to shut down this interface, and this is the command to shut down this interface. As you can see here, this is actually one command in 2 lines, and this is also one command in 2 lines. The idea here is that it is common to avoid exceeding 80 characters in your line to make reading the program easy. You want always to keep number of characters in your line at low value, 80 or less. And if your line is expanding more than 80 characters, you can easily click enter and have the same command into 2 lines. So these 2 lines actually are one command, but it was split into 2 lines. How Python knows these 2 are the same command? Because at the end of the command you need to close all the brackets that you started. So somehow Python is intelligent enough to know that these 2 lines are actually one command, and it will take an action based on these 2 lines. So let's go back to our script. So this script is very simple also. I use the same time function to calculate the time consumed or the time elapsed during this script. I log in, and then I have the counter or the loop that runs from 1 to 29. For every interface, I will collect the VLAN tag that's applied right now in that interface. I'll remove the first 22 characters of this string because the string is long. It will include many other details that I don't care about. I care only about VLAN number. And then if VLAN number is 3, I want to shut down that interface, and then once the counter is completed for 29 interfaces, I want to log out. And at the end, I want to calculate the time elapsed or the duration of this script. I have the same script created twice, one as API and the other as CLI, and I use the same counters in both scripts. This script is using CLI, it runs also from 1 to 29, and this one here is using API. So let's start by see the interfaces I have right now. So if we try show interface brief, I don't have any interface that is shut down, but I have many interfaces that are part of VLAN 3. For example, I have these interfaces part of VLAN 3, interface 10, 11, 15, and 19. As you can see here, VLAN 15 and 19 are trunks, but I want to shut down even in trunk interfaces if the native VLAN is 3. So let's run the script and see the result. So the script name is VLAN API.python. So the script shut down 4 interfaces because as per this print command, I want to print every interface that's part of VLAN 3 and shut it down. To verify, we can run this command again. As you can see, the interfaces 10, 11, 15 and 19 are shut down now. So the API script shut down these interfaces because they are part of VLAN 3. If you try show run, for example, and you go to one of these interfaces, 10 for example, you will see this shutdown interface that was initiated by the API. This script took about 0.8 seconds. So this API took less than 1 second. Actually, it took 0.8 seconds to shut down interfaces that are part of VLAN 3. Let's try to run the same script but using CLI, which is this one. Before doing this thing, let's enable these interfaces again. So right now I enable these interfaces. No interface in admin state, the admin down, they are not shut down. And now let me run the CLI script. So instead of API, I will run CLI. As you can see now, it's taking more time to run CLI scripts, much more than API scripts. And let's give it some time for the script. It starts giving the results. They are the same interfaces, 10, 11, 15, and 19, that are shut down by this script. Let's verify. Okay, these interfaces are shut down again. But let's see the time duration. It is more than 30 seconds. So for CLI script to achieve the same function, the CLI script needed more than 32 seconds. Compared to the API that took less than 1 second. So as you can see here, the API script was much faster than CLI script, and even actually retrieving the data and writing the data was much easier using JSON than running the CLI script and retrieving the data by parsing the output. In CLI, we need to parse the output, or sometimes they call it screen scrapping. In CLI, we need to parse the output to get the result, while in API, we depend on JSON to do this for us and give us the clean output ready to be read and to be written. So that's all for our lesson today. So today we talked about the Swagger interface, which is an easy way to read the variables and read different API format. And we compared API and CLI scripts to find out that API scripts are much faster than CLI scripts. Thank you. So in this session, we discussed the Swagger interface and we saw how easy it is to read API data and to read the format for different parameters in the API. We understood different request types like GET, which is mainly for reading, POST, which is mainly to create resources, PUT, which is to modify certain parameters in the interface or in the resource, and delete, which is mainly to delete the resource. We discussed the concept of login, logout, and how we can use it in the session format to create cookies and use them in the subsequent request. These cookies will be released once we log out from that API session. We discussed response code, and this should be 200 for the successful API request. We discussed JSON format and the concept of key value pairs, which is called dictionary in Python. And we run two different API scripts. One of them was mainly to get the software version, and the other one was to shut down the interface. And we saw that these scripts needs less than 1 second to run in API script, while the same function needed more than 30 seconds using CLI scripts. So we were able to compare the time needed for API against CLI. I hope this was a useful session for you. Thank you and have a great day.